The machines that changed forestry forever weren't born from careful planning or gradual innovation. They emerged from one man's obsession with solving an impossible problem, and the solution he created would reshape entire industries in ways nobody could have predicted. But what was this problem that seemed so unsolvable? What made traditional methods so inadequate that someone had to dream up machines that looked like they belonged in science fiction rather than the lumber yards of mid-century America? Robert Gilmour LeTourneau wasn't your typical inventor. Born in 1898 in Richford, Vermont, he dropped out of school after the 7th grade. This lack of formal education, rather than holding him back, became his greatest asset. Why would less education help someone revolutionize industrial machinery? The answer lies in how he approached problems. Without the constraints of conventional engineering training, LeTourneau looked at challenges with fresh eyes, unburdened by the assumption that certain things simply couldn't be done. His mind worked differently, seeing possibilities where trained engineers saw only limitations. The logging industry in the early 20th century faced a crisis. By the way, if you're passionate about these stories of engineering, strength, and industrial heritage, here you'll discover documentaries about legendary tractors, colossal machines, and the equipment that transformed agriculture, mining, and construction. Subscribe, and every week we'll explore together how these machines changed the world and the way we work. After this brief pause, we continue. That threatened its very existence. Forests across North America contained millions of acres of valuable timber, but getting to those trees and processing them efficiently remained brutally difficult and dangerous work. Traditional methods required teams of men with axes and saws, horses or oxen for hauling, and backbreaking labor that could take days to fell a single, large tree. The cost in human life and injury was staggering. Workers died regularly from falling trees, broken equipment, and exhausted animals. But beyond the human toll, there was an economic reality that couldn't be ignored. How could logging companies make operations profitable when the process moved at such a glacial pace? LeTourneau had already made his name in earth-moving equipment by the 1930s. His scrapers, bulldozers, and other heavy machinery had transformed construction sites around the world. During World War II, his equipment became essential to military operations, building airstrips, roads, and fortifications at unprecedented speeds. The U.S. military relied on his design so heavily that he earned the nickname God's Businessman for his unique combination of engineering genius and deep religious faith. Yet even with all these accomplishments, the forestry challenge intrigued him in a way that nothing else had. Why would someone already successful and wealthy take on such a difficult new challenge? The answer came down to waste. LeTourneau saw logging operations and recognized that the industry threw away more value than it captured. Small trees that fell during harvesting, branches stripped from main trunks, stumps left in the ground, and the massive amount of time required to clear land before planting new crops all represented lost opportunity. What if there was a way to process entire forests quickly, efficiently, and safely? What if machines could do in hours what took men weeks or months? The potential wasn't just about making logging easier, it was about fundamentally reimagining humanity's relationship with forest management. By the late 1940s, LeTourneau had begun sketching designs for machines that would make most engineers shake their heads in disbelief. Picture a vehicle that stood 3 stories tall, weighed hundreds of tons, and could grab trees like toothpicks, snap them off at the base, and process them into usable lumber in a single continuous operation. It sounds absurd, doesn't it? Yet this wasn't fantasy. This was LeTourneau's vision for what became known as the tree crusher, though that simple name barely captured the awesome capability of these mechanical giants. The first prototype emerged from his workshops in Longview, Texas in 1953. Workers who saw it being assembled couldn't quite believe what they were building. The main boom alone stretched over 100 feet long. The crushing jaws at the business end could exert thousands of pounds of pressure. But here's what made the design truly revolutionary. Instead of cutting trees, which required precise angles and sharp blades that dulled quickly, LeTourneau's machine simply crushed them. What advantage did crushing offer over cutting? The physics were beautifully simple. A tree might be extremely strong along its length, able to withstand high winds and heavy snow, but apply perpendicular pressure at the right point and even the mightiest trunk becomes vulnerable. The crusher didn't fight the tree's natural strength. It exploited its inherent weakness. Testing the first tree crusher proved more challenging than building it. The machine was so large and powerful that finding a safe location to operate it became a project in itself. LeTourneau's team cleared a section of forest on company land and positioned the crusher at the edge. As the engine roared to life, a sound unlike anything heard in nature rumbled across the landscape. The boom extended, the jaws opened, and slowly, almost gently, the operator maneuvered the crusher toward a pine tree about 2 feet in diameter. What happened next would either validate years of work or send the team back to the drawing board. The jaws closed around the trunk about 6 feet above the ground. Hydraulic pressure built. For a moment, nothing seemed to happen. Then came a crack that echoed like a rifle shot. The tree's fibers began to fail. Another crack. Then a cascade of splintering sounds as the trunk simply gave way. But the machine didn't stop there. As the tree fell into a horizontal position, still gripped by the jaws, a secondary set of crushers activated. These processed the trunk into manageable sections, stripping away branches and reducing what had been a living tree into processed timber in less than 2 minutes. 2 minutes! Think about that. A job that would have taken 2 experienced loggers with chainsaws 15 or 20 minutes had just happened in less time than it takes to brew coffee. The implications rippled outward immediately. If one machine could process a tree in 2 minutes, how many trees could it handle in an hour? In a day? The mathematics were staggering. A skilled logging crew of 10 men might fell and process 30 to 40 trees in a 10-hour workday under good conditions. One tree crusher, operated by a single person, could theoretically process 150 to 200 trees in the same time frame. But could the machine maintain that pace? Could it handle different species of trees, different terrains, different weather conditions? LeTourneau's engineers spent the next 2 years refining the design and testing it under every condition they could imagine. They took the crusher into swamps where the ground became so soft that conventional vehicles would sink to their axles. The machine's wide tracks, inspired by those on military tanks, distributed weight so effectively that it barely made an impression on soggy ground. They tested it on steep hillsides where traditional logging was nearly impossible. The crusher's low center of gravity and powerful stabilizers kept it upright even on slopes that seemed impossibly steep. They ran it in freezing temperatures where hydraulic fluid turned sluggish and metal became brittle. The machine kept working. But one question kept emerging during these tests. What about really big trees? The crusher could handle the trunks up to 3 feet in diameter fairly easily, but the Pacific Northwest held Douglas firs and redwoods 6, 8, even 10 feet across. Could the machine scale up to handle these giants? LeTourneau's answer was characteristically bold. He didn't design a bigger crusher. He designed a different approach entirely. For truly massive trees, LeTourneau developed what he called the mobile tree shear. Instead of crushing the trunk, this machine used enormous hydraulic shears that operated like scissors, cutting through wood fibers cleanly and quickly. The shears could sever a 6-foot diameter tree in under 5 minutes, faster than any team of loggers with saws could hope to match. But why develop two different types of machines instead of one universal design? The answer reveals LeTourneau's practical genius. Different jobs required different tools. Crushing worked perfectly for smaller trees and dense forest where speed mattered most. Shearing excelled with larger specimens where the goal was preserving the trunk's integrity for high-quality lumber. By offering both options, LeTourneau gave forestry companies flexibility they'd never had before. The tree crusher's first major commercial deployment came in 1955 when a large timber company in Louisiana contracted with LeTourneau to clear 3,000 acres of mixed pine and hardwood forest. The company wanted to prepare the land for agricultural use, but traditional methods would have taken 18 months and cost hundreds of thousands of dollars. LeTourneau proposed using 4 of his tree crushers to complete the job in 6 months for half the estimated cost. The timber company was skeptical. How could 4 machines, even impressive ones, replace the dozens of men and months of labor that conventional wisdom said the job required? The contract included performance benchmarks. If LeTourneau's machines didn't meet specific quotas, he would forfeit payment. If they exceeded expectations, he would earn substantial bonuses. It was a high-stakes bet, but LeTourneau believed in his machines. The 4 crushers arrived on site in March of 1955. Operators who had been trained at LeTourneau's facility in Texas began work immediately. Within the first week, the skeptics became believers. Each machine was processing an average of 175 trees per day. At that rate, the 4 crushers were handling 700 trees daily. The contract had estimated that clearing 3,000 acres containing approximately 90,000 trees would require 18 months. The crushers were on pace to finish in 4 months. But could they maintain that pace? Industrial equipment often performs well initially but degrades over time. Maintenance becomes more frequent, breakdowns occur, and efficiency drops. LeTourneau had anticipated this. His machines were overbuilt, constructed with tolerances far exceeding what the work required. Components that might reasonably have been expected to last 6 months were designed to last 2 years. Hydraulic systems included redundancies so that minor leaks or failures wouldn't shut down the entire machine. Each crusher came with a full set of replacement parts and a maintenance schedule that prevented problems before they occurred. This approach cost more upfront, but paid enormous dividends in reliability. By the end of June, just 4 months after starting, the Louisiana project was 90% complete. The timber company had already begun agricultural operations on cleared sections, while the crushers finished the remaining acreage. The final accounting showed that LeTourneau had cleared 3,000 acres in 4.5 months at 60% of the estimated cost using conventional methods. The company saved over $200,000, a fortune in 1950s money. More importantly, they'd proven that mechanized forest clearing was not only possible but economically superior to traditional approaches. Word spread quickly through the timber industry. By 1956, LeTourneau had orders for 37 tree crushers from companies across the United States and Canada. Production ramped up at his manufacturing facilities. But this rapid success created a new problem. Who would operate these machines? The tree crusher required skills that didn't exist in the workforce. It wasn't quite like driving a bulldozer or operating a crane. It required elements of both, plus an understanding of tree mechanics, terrain assessment, and equipment maintenance. LeTourneau established a training program at his Texas headquarters. Candidates came from logging crews, heavy equipment operators, and military veterans with mechanical experience. The training lasted 6 weeks and covered everything from basic machine operation to advanced troubleshooting. Interestingly, LeTourneau discovered that the best operators often weren't the most experienced heavy equipment veterans. Why would less experience sometimes be better? The answer mirrored LeTourneau's own journey. Experienced operators had ingrained habits from conventional equipment. They approached the tree crusher with preconceptions about how such a machine should work. Newcomers with less baggage learned the crusher's unique characteristics more quickly and often developed more efficient operating techniques. One graduate of that training program, a former Army mechanic named Thomas Harrison, went on to become legendary in the forestry industry. Harrison operated a tree crusher in Oregon for 12 years, and during that time, he developed techniques that increased efficiency by another 20% beyond what LeTourneau's engineers had thought possible. How did he do it? Harrison studied tree species and learned to read subtle signs that indicated internal rot, lean, or other factors that affected how a tree would respond to the crusher. He could look at a stand of trees and plan an optimal processing sequence that minimized machine movement and maximized throughput. His innovations were eventually incorporated into operator training programs and became standard practice. But the tree crusher's impact extended far beyond commercial logging. In 1957, the U.S. Forest Service contracted with LeTourneau to clear firebreaks in California's Sierra Nevada mountains. Wildfires had ravaged the region for 3 consecutive summers, and traditional firebreak construction was too slow to prepare adequate defenses before fire season began each year. Could the tree crushers create firebreaks fast enough to make a difference? The Forest Service wanted 50 miles of firebreak, each line 200 feet wide, completed in 3 months. It seemed impossible. LeTourneau deployed 8 machines and crews who worked in rotating shifts to operate around the clock. The terrain was brutal. Steep mountainsides, rocky soil, and trees of varying sizes created challenges that the flat forest land of Louisiana hadn't presented. Yet the crushers proved remarkably adaptable. They're stabilizing. By the way, if you're interested in understanding how great machines were born, the industrial brands that dominated their era, and the technology that drove progress, this channel offers real stories every week that combine innovation, ambition, and mechanical power. Subscribe and discover the secrets behind the machines that moved the world. Now let's return to the story. Systems kept them level on slopes up to 45 degrees. The crushing jaws handled rocky soil without damage. Within 6 weeks, 42 miles of firebreak were complete. The final 8 miles were finished with 2 weeks to spare. That summer, a lightning strike ignited a fire that grew into one of the largest wildfires California had seen in decades. The flames raced through the forest, consuming everything in their path. But when the fire reached the firebreaks that LeTourneau's machines had created, it stopped. The 200-foot-wide cleared zones contained nothing to burn. The fire burned along the perimeter, unable to cross, and eventually exhausted itself. Those fire breaks saved an estimated 15,000 acres of old-growth forest and protected 4 small mountain communities that were directly in the fire's path. How many lives did those machines save? How much property? The value couldn't be measured in dollars alone. The success of the tree crushers created unexpected opportunities in land management and agriculture. In the Amazon rainforest, farmers struggled to clear land for crops. The dense jungle, with trees large and small packed tightly together, resisted traditional clearing methods. Farmers would spend years clearing a single acre, only to have the jungle reclaim it within months if they couldn't maintain the cleared space. A Brazilian agricultural cooperative contacted LeTourneau in 1958 with an unusual proposal. They wanted to lease tree crushers to help small farmers clear land for coffee plantations. Could the machines that had proven themselves in North American forests handle the unique challenges of tropical rainforest? LeTourneau was initially hesitant. The Amazon presented problems his engineers had never considered. The humidity was extreme, temperatures soared during the day, and the variety of tree species was staggering. Some rainforest trees had wood so dense that conventional saws broke trying to cut them. Others contained natural rubber that clogged cutting equipment. And the crushing method that worked so well on pine and hardwood might not work the same way on species that had evolved different structural properties. But the challenge intrigued him. He agreed to send 2 modified crushers to Brazil for a 6-month trial. The modifications proved crucial. Engineers added enhanced cooling systems to handle the tropical heat. They upgraded hydraulic pumps to maintain pressure in high humidity. Most importantly, they reinforced the crushing jaws with a new steel alloy that could handle the incredibly dense tropical hardwoods. The machines arrived in Brazil in February of 1959 and went to work in a test area near Manaus. The first week was rough. Operators discovered that many rainforest trees, particularly older specimens, had enormous root systems that spread wide rather than deep. The crushers would process the trunk successfully, only to find the tree still partially connected by massive surface roots. How could they handle this unexpected obstacle? The solution came from one of the Brazilian operators who suggested crushing the root system first, severing the major roots before tackling the trunk. This added time to each tree, but proved to be the only reliable method. Despite the learning curve, the trial succeeded. By the end of 6 months, the 2 crushers had cleared 200 acres of dense rainforest. The Brazilian cooperative immediately ordered 6 more machines, but this success raised important environmental questions. Was mechanized rainforest clearing ecologically responsible? The crushers were so efficient that they could clear forest much faster than it could regenerate. What safeguards would prevent misuse? LeTourneau, always mindful of the ethical implications of his work, insisted that buyers in sensitive ecological areas like the Amazon agree to reforestation plans. For every acre cleared, they had to commit to maintaining protected forest elsewhere. This wasn't legally enforceable, but LeTourneau refused to sell machines to buyers who wouldn't make that commitment. Did everyone honor their promises? Probably not. But LeTourneau had tried to balance technological progress with environmental responsibility, a forward-thinking approach that was rare in the 1950s. Back in the United States, the tree crusher was evolving. By 1960, LeTourneau had developed the Mark IV crusher, the 4th generation of the original design. This version incorporated lessons learned from thousands of hours of operation in diverse conditions. It was more powerful, more reliable, and more efficient than earlier models. The Mark IV could process trees up to 4 feet in diameter and handle up to 250 trees per day in optimal conditions. But the most significant improvement was in operator comfort and safety. Early crushers required operators to sit in exposed cabs where noise, vibration, and weather made the job physically demanding. The Mark IV featured an enclosed, climate-controlled cab with advanced ergonomics. Noise-dampening technology reduced the deafening roar of earlier models to manageable levels. Visibility improved through larger windows and strategically placed mirrors. These might seem like minor upgrades, but they had major impacts. Operator fatigue decreased, safety improved, and productivity increased because operators could work longer shifts without exhaustion. One fascinating application of tree crushers emerged in the early 1960s, when the interstate highway system began its massive expansion. Construction crews needed to clear rights-of-way through forested areas across the country. Traditional methods created bottlenecks. Highway construction crews would be ready to grade and pave, but they'd be waiting for logging crews to finish clearing. The tree crusher changed this dynamic completely. How much time did mechanized clearing save on a typical interstate highway project? A study conducted by the Federal Highway Administration in 1963 examined 3 comparable highway sections, each 10 miles long, through similar forested terrain. One used traditional logging crews, one used a combination of traditional methods and early model tree crushers, and one used exclusively Mark IV crushers. The results were dramatic. Traditional methods took 11 months to clear the 10-mile section. The combination approach took 6 months. The Mark IV crushers completed their section in 7 weeks. 7 weeks versus 11 months. The crushers weren't just faster. They changed the entire project, timeline, and economics. But the crusher's capabilities extended beyond simple tree removal. In 1964, Hurricane Hilda struck Louisiana with devastating force. The storm's 130-mile-per-hour winds leveled thousands of acres of forest, creating a tangled mess of fallen trees that blocked roads, threatened communities, and posed a serious fire risk if left uncleared. Traditional cleanup methods would have taken years. Insurance companies estimated that storm debris removal costs would exceed $10 million. Louisiana's governor called LeTourneau directly and asked if his machines could help. LeTourneau mobilized 12 tree crushers from various sites around the South. They converged on Louisiana within 48 hours. But this wasn't like working in an intact forest. Hurricane debris presented unique challenges. Trees were down, tangled together, often partially buried in mud and debris. Root balls had been torn from the ground, creating massive clumps of soil and wood. How could machines designed to crush standing trees adapt to this chaos? The operators improvised brilliantly. They used the crusher's power to drag debris into piles, then processed everything together. The crushing jaws proved surprisingly effective at untangling snarled trees. Within 3 months, the 12 crushers had cleared over 90% of the hurricane damage. The final cost came in at $4 million, less than half the original estimate. The state of Louisiana was so impressed that they purchased 4 crushers for their Department of Transportation to keep on hand for future emergencies. This emergency response capability became another market for LeTourneau's machines. By 1965, crushers were stationed at strategic locations around the country, ready to deploy when disasters struck. They became essential tools for dealing with ice storm damage, tornado aftermath, and forest fire cleanup. The machines that had started as logging equipment had evolved into multi-purpose disaster response tools. The military took notice. During the Vietnam War, U.S. Army engineers faced constant challenges clearing jungle for landing zones, fire bases, and roads. Could tree crushers work in a combat environment? The Army ordered 6 specially modified machines in 1966. These featured armor plating to protect operators from small arms fire, self-sealing fuel tanks, and redundant systems so that damage to one component wouldn't disable the entire machine. The military crushers arrived in Vietnam in early 1967 and immediately proved their worth. Engineers could clear a landing zone large enough for multiple helicopters in under 2 hours. Building a fire base that would have required several days of work with conventional equipment could be done in a single day, but operating in a war zone created problems that peacetime use never encountered. How do you maintain complex hydraulic machinery when spare parts and maintenance facilities might be hundreds of miles away? Army mechanics developed field-expedient repairs that kept the crushers running even when proper parts weren't available. They learned to improvise seals from materials at hand, jury-rig hydraulic lines, and keep the machines operational under conditions that would have sidelined civilian equipment. These military experiences fed back into civilian designs. The Mark V crusher, introduced in 1968, incorporated military-grade durability while maintaining the efficiency of civilian models. By 1970, tree crushers were operating on 6 continents. They cleared land in Australia's outback, processed forest in Scandinavia, and helped with agricultural development in Africa. Each environment presented unique challenges and taught lessons that improved future designs. In northern Canada, crushers worked in temperatures 40 below zero. In equatorial Africa, they operated in 120-degree heat. The machines proved remarkably adaptable, a testament to LeTourneau's original overbuilt design philosophy. But by the early 1970s, a new challenge emerged. Environmental consciousness was rising. People began questioning whether massive mechanized forest clearing was ecologically wise. Critics argued that crushers made deforestation too easy, that they enabled habitat destruction at unprecedented scales. These weren't unfair criticisms. The same efficiency that made crushers valuable also made them potentially destructive if used irresponsibly. How should LeTourneau's company respond to these legitimate concerns? The answer came through a surprising partnership with environmental organizations. In 1973, LeTourneau Corporation worked with the Sierra Club and Nature Conservancy to develop best practices for responsible crusher use. These guidelines addressed when crushing was appropriate, what environmental assessments should precede, clearing, and how to minimize ecological impact. Crushers began being used for selective clearing that actually improved forest health by removing diseased trees and reducing fire fuel loads while leaving healthy specimens intact. This more nuanced approach opened new markets. State and federal forestry agencies bought crushers for forest management rather than wholesale clearing. The machines that had once seemed like instruments of destruction became tools for ecosystem health. A crusher could selectively remove invasive species that were choking out native trees. They could create controlled gaps in dense forests that allowed sunlight to reach the forest floor, promoting diverse undergrowth. In fire-prone regions, they created strategic thinning that reduced wildfire intensity while preserving the forest itself. Robert LeTourneau passed away in 1969, but his company continued innovating. Before we finish, remember that we created this channel with one purpose in mind: to rescue the stories of heavy machinery that reveal how engineering, hard work, and industrial vision shaped our modern history. Because understanding these machines means understanding progress, human effort, and their impact on the world. Subscribe and become part of this community that loves to discover the secrets of the industrial past. With that said, let's continue. By the mid-1970s, tree crushers incorporated early computer controls that helped operators work more precisely. Sensors could measure tree diameter, assess lean, and calculate optimal crushing points automatically. These systems increased efficiency and reduced waste by helping operators make better decisions in real time. One of the most interesting late developments came in 1977 with the introduction of the recovery crusher. Earlier, machines simply crushed trees and left the debris for later processing or burning. The recovery crusher included integrated chippers that converted crushed trees directly into wood chips suitable for paper production or biomass fuel. This closed the loop, turning what had been waste into valuable products. A logging operation could now extract value from every part of every tree, from the main trunk down to the smallest branches. The economics became compelling. A timber company could clear land, process trees into lumber and chips, and generate wood-based fuel to power their own operations, all with the same machine. This integrated approach reduced costs while increasing yield. By 1980, recovery crushers dominated new sales. The old-style crushers that simply reduced trees to debris were becoming obsolete. But perhaps the most surprising legacy of LeTourneau's tree crushers came in the 1980s with the rise of recycling and waste management. Engineers realized that the same principles that made tree crushers so effective could apply to other materials. Modified crushers began processing construction debris, crushing concrete and metal into recyclable components. They handled disaster cleanup, processing the remains of demolished buildings efficiently. They even found applications in mining, crushing ore-bearing rock. The tree crusher had evolved far beyond its original purpose. What started as a solution to forestry challenges had become a general-purpose tool for processing tough materials quickly and efficiently. Today, machines descended from LeTourneau's original crusher's work in dozens of industries worldwide. The fundamental design remains recognizable, even after more than 70 years of evolution. Looking back, what made LeTourneau's tree crusher so revolutionary? The technology was impressive, certainly, but the real innovation was conceptual. LeTourneau didn't just make existing processes more efficient, he reimagined the entire relationship between human industry and the natural environment. His machines gave humans unprecedented power to shape landscapes. That power came with responsibility, a lesson that took decades to fully appreciate. The story of the tree crusher is ultimately a human story. It's about one man's refusal to accept limitations, about operators who learned to coax maximum performance from massive machines, about engineers who continuously improve designs based on real-world experience. It's about industries transformed, landscapes altered, and the complex balance between human needs and environmental stewardship. Today's forest management practices owe an enormous debt to those early tree crushers. The machines forced the industry to think bigger, work faster, and eventually think more carefully about long-term impacts. The efficiency they brought created the economic space for environmental considerations. When clearing took months and cost fortunes, companies couldn't afford to be selective. When crushers could do the work in weeks for less money, there was room to think about doing it right rather than just getting it done.